9.1. This is the Arrhenius equation. Natural log of your rate constant equals activation energy, negative activation energy divided by the gas constant divided by the temperature in Kelvin, plus natural log of a constant called the Arrhenius constant. So first of all, it guides you through. You've got the rate constants here. You need to press the natural log button and work out natural log of each of these rate constants, and you need to divide each of these numbers into 1, so 1 divided by each of these numbers, and you should end up with a table that looks like that. When it now says plot a graph of natural log k against 1 over t, you always do y against x. So natural log of k, ln k, goes up the y-axis, and 1 over t goes along the bottom axis. Now when you're plotting the bottom axis, you can just use these whole numbers, 1.43, 1.38, 1.34, and 1.26, and put times 10 to the minus 3 in brackets on your label. And then you should end up with a graph that looks a bit like this. It will come down, it'll be a straight line as long as you label your axis. Put natural log of k up the y-axis and 1 over t along the bottom axis. You put your points, plot your points accurately, and your line, draw a line of best fit through the points, and it covers at least half the graph paper. You'll get your marks for drawing your graph. Now the gradient is the change in y divided by change in x. So you measure the change in y and you divide by the change in x, and it will come out as a negative number, minus 2.88 times 10 to the minus 4, or close to that. Because the line is coming down in this way, it's a negative number. Now you may remember from GCSE maths, y equals mx plus c, so m is your gradient and c is a constant, and that resembles this equation here. Y, your y-axis, equals your x-axis is 1 over t, and this is a constant. So the rest of it, minus EA over R, is your m, which is your gradient. In other words, minus EA over R is your gradient. So if you reverse both signs, then 2.88 times 10 to the power of 4 equals your activation energy divided by your gas constant, 8.314. Multiply the two numbers together, you get EA, and that is in joules per mole. You know it's in joules per mole because your gas constant is in joules per Kelvin per mole. So it actually wants it in kilojoules per mole, so to convert small joules into kilojoules, then you're dividing by 1,000, so 2.39 times 10 to the power 3 joules per mole equals 239 kilojoules per mole.